Hello guys, welcome to the channel Mathemagix JEE. So today we are going to discuss the part 2 of the mock paper that I already posted, and part 1 I will link in the description. You can check it out after watching this discussion. So this is the question number 11. Here it says the value of this expression equals. So this is a limit. We have to solve this limit for x tending to 0. Now the first step that we need to do here is rationalizing this denominator. So we multiply both numerator and denominator by this term. So now this denominator can be simplified as x square. This becomes x square plus 2 sine x plus 1 minus sine square x plus x minus 1. So these get cancelled, and so this whole term becomes x square plus sine square x plus 2 sine x plus x. So the limit becomes limit x tending to 0, x plus 2 sine x divided by x square plus sine square x plus 2 sine x plus x times limit x tending to 0 root under x square plus 2 sine x plus 1 plus root under sine square x minus x plus 1. Now this part we can evaluate this limit easily. It becomes 1 plus 1. So this becomes 2. That means the overall limit will be 2 times this limit. Now this limit is of the form 0 by 0. You can observe if we tend x to 0, this limit is of the form 0 by 0. So we can apply L'Hopital rule here. It becomes limit x tending to 0 1 plus 2 cos x divided by 2x plus sine 2x. Derivative of sine square x becomes sine 2x plus 2 cos x plus 1, and here is a 2 outside. So this limit becomes 2 times limit extending to 0 will give us 1 plus 2, that is 3 in the numerator, and in the denominator it will give us 0 plus 0 plus 2 plus 1, so again 3. So our answer becomes simply 2. So 2 is the correct answer. That means option B is the correct option. I hope you understood this question. Let's proceed with the next question. This is the 12th question. Here it says function is given in terms of a determinant. It is a polynomial of degree 7 such that f of x is a naught x to the power 7 plus a1 x to the power 6 plus so on up to a7. Then this sigma is asked. So this sigma, if we expand it, it will become a naught plus a2 plus a4 plus a6. So that means we have to find the sum of these 4 coefficients. Now we observe there that fx is given like this. So f of 1 will be simply the sum of all coefficients. So f of 1 will be a0 plus a1 plus a2 plus A3 plus A4 plus A5 plus A6 plus A7. Now here if we put x equal to -1, then it becomes minus A0 plus A1 minus A2 plus A3 minus A4 plus A5 minus A6 plus A7. So the terms will have alternating plus minus sign. That means if we want to calculate the sum A0 plus A2 plus A4 plus A6, we need to simply subtract these two. So we get f of 1 minus f of minus 1 is equal to, so this becomes 2 times A0 plus A2 plus A4 plus A6. So this is our required sum. Let us call this S. So S becomes half of f of 1 plus, minus f of minus 1. Now f of 1 we can calculate easily from this definition of fx. So f of 1 will be simply putting x equal to 1 in this determinant. It becomes 2, then 1, then 4, then 4, then 3, then minus 2, then minus 2, then 5, then 2. So it becomes 2 times 21 minus 1 times 4 plus 4 times 26. This becomes 42 minus 4 plus 104. This becomes 104 plus 38, so 142. Now similarly we can calculate f of minus 1. This becomes 4 minus 36, so minus 32. So S is half of f of 1 is 142 minus f of minus 1 is minus 32, so overall plus 32. So this becomes 71 plus 60. That means it becomes 87. Maybe I did some calculation mistake here. Let me check. So this will be 16. I think I did a calculation mistake here. This will be 16. So this will be 32. So this will be 132. Let me correct myself. This value will be equal to 66 plus this will be 16. So the answer will be 82. So option C is the correct option. So be careful in this type of questions where calculations matter. This is the next question. Let the sum of two positive integers be 24 if the probability of their product not being less than 3 by 4 times their maximum possible product is this, where the product of x and y is equal to the least common multiple of x and y. So from this two line we can deduce that product of these two numbers is equal to LCM of these two numbers. Now product of any two given numbers we can write them as LCM of them times HCF or GCD, you can say anything. We can write them like this. So LCM will get cancelled and we will get HCF of x and y is 1, or greatest common divisor of x and y is 1. That means x and y should be co-prime. Now here the question statement says let the sum of two positive integers be 24. So we can assume those two positive integers as m and n. So m plus n must be 24. And m is positive integer and n is positive integer. Now if the probability of their product not being less than 3 by 4 times their maximum possible product, so we can apply AM-GM inequality here because m and n are positive integers. So the maximum possible value of the product mn will be m plus n by 2 whole square. That means 144 in this case. So we need to put their product mn as greater than equal to 3 by 4 times 144. That means mn should be greater than equal to, this will be cancelled by a factor of 36 and then 108. Now from these two informations we need to find the cases or the ordered pairs m and n. So from here we get m into 24 minus m should be greater than equal to 108. That means m square minus 24m plus 108 should be less than equal to 0. Now from here we can apply the wavy curve method. For this we need to find the roots of this equation. That means m is equal to 24 plus minus whole square of 24 is 576 minus 4 times 108, that is 432 divided by 2. So this is equal to 12 plus minus, this will be equal to root under 441. So root under 144 is 12. So means this will be 12 plus minus 6. That means m is equal to 12 plus 6, that is 18, or m is equal to 12 minus 6, that is 6. So from here we can say that this quantity will be less than equal to 0 if m belongs to closed 6 to 18. Now for this m values, n should belong to 6, 18 closed interval also. You can derive it from this relation 1 and this is relation 2. So from here we get total ordered pairs mn. The total number of ordered pairs will be total values of m, integer values of m, that are total 13 in number. You can count them, so it will be 13, and we can calculate the probability. Now here total favorable cases are 13 and total number of cases or total number of ordered pairs m comma n, that will be equal to, you can count them as m n. So m starts from 1 and goes to 23, and then n starts from 23 and goes to 1. We will not consider the case m equal to 24 and n equal to 0 because we are told that n should be a positive integer. That means here are 23 cases in total. So the probability will be favorable upon total. That means 13 over 23. This is told that this ratio is equal to x by y, where x and y are co-prime. So x is 13 and y is 23. That means the value of y minus x is asked in the question. So y minus x will be 10 in this case. So option A will be the correct option. I hope you understood this question. Now the next question is from the chapter complex numbers. Let S be this set where Z belong to the set of complex numbers such that Z bar, that is Z conjugate, is equal to iota times Z square plus real part of Z bar. We can simplify this equation by putting Z equal to x plus iota y. So this equation will be Z bar is x minus iota y. It is equal to iota times Z square. We can calculate x square minus y square plus 2xy iota plus real part of z bar is x. So this equation simplifies as x minus iota y is equal to minus 2xy plus iota times x plus x square minus y square. Now we can simply equate the real part of LHS with the real part of RHS and imaginary part of the LHS with the imaginary part of RHS. So this becomes minus 2xy equal to x. It is our equation 1. And similarly minus y is equal to x plus x square minus y square. This is our equation 2. Now from equation 1 we get x plus 2xy is equal to 0. That means x into 1 plus 2y, it is equal to 0. That means x is 0 or y is equal to minus half. There are two possibilities. Now from equation 2 we get x square minus y square plus x plus y equal to 0. That means x minus y plus 1 times x plus y equal to 0. From here we get y is minus x or y minus x is 1. So we have altogether 4 possibilities. Now if we consider case 1 for which x is equal to 0. Now for x equal to 0 we have to simply consider these two cases. That means the first possibility is y equal to minus x, so y is 0, and the second possibility is y minus x, that is 0, is minus 1. That means y is minus 1. So from here we get two values of z that are 0 0, that is the origin itself, and the point 0 comma minus 1, these two. Now if we consider a second case, case 2, for which y is minus half. Similarly from these two cases, in the case 2 we get if y is minus x then x should be half, and in the second possibility if y minus x is equal to 1, that means x should be y minus 1. So x should be minus 3 by 2. So from here we get another two complex numbers that are half comma minus half and minus 3 by 2 comma minus half. So there are altogether 4 complex numbers in this set S. So we got 4 complex numbers z1, z2, z3, z4, which are 0 0, then 0 minus 1, then half comma minus half, and minus 3 by 2 comma minus half. So mod of z1 will be 0, mod of z2 will be 1, mod of z3 will be root under 1 by 4 plus 1 by 4, so 1 by root 2, and similarly z4 modulus will be root under 9 by 4 plus 1 by 4, so root over 10 by 4, that is root over 5 divided by root 2. So we are asked to calculate the sum of squares of all the moduli of those complex numbers that belong to the set S. So from here we get modulus of z1 square plus modulus of z2 square plus modulus of z3 square plus modulus of z4 square is equal to 0 plus 1 plus half plus 5 by 2. This is simply equal to, this is 6 by 2, so 3 plus 1, that is 4. So option B will be the correct option for this question. I hope you understood this question. This is the 15th question. it says the coefficient of variation of first 28 natural numbers is, and 4 options are given. So now we have to recall what a coefficient of variation is. The definition of coefficient of variation that we denote by CV, it is equal to the standard deviation divided by the mean into 100%. So this is the coefficient of variation. Now you have to simply use this formula to derive the coefficient of variation for first 28 natural numbers. Now we know that standard deviation of first 28 natural numbers, it is equal to root over n square minus 1 divided by 12. This is a standard formula you have to remember. You can also derive it by using the definition of standard deviation, that is sigma x square divided by n minus sigma x divided by n whole square and under root of this whole expression. Now this is a standard result, so we remember it. Now what is the mean of n natural numbers? It is equal to n into n plus 1 divided by 2 divided by n. So it is equal to n plus 1 by 2. That means the coefficient of variation becomes n plus 1 by 2. It will come in the denominator, and in the numerator it will be root under n square minus 1 divided by 12 into 100. So this becomes 2 divided by n plus 1 into root under n square minus 1 divided by 12 into 100. Now we have to simply put n equal to 28 in this expression. So this expression becomes 2 over 29, and this becomes 28 square minus 1 square divided by 12 into 100. We wrote this in this form because the calculation will be simpler. So it becomes 2 by 29 into, this becomes root over 27 into 29 divided by root 12, we can write as 2 root 3 into 100. So this becomes 2 gets cancelled, and here this we can write as root 29 into root over 27 by 3 divided by 29 into 100. Now root over 27 by 3 gives us root over 9. So this whole value is equal to 3. That means our answer becomes 300 divided by root over 29. Now many of you may get stuck in this step because we are not allowed any calculator or any type of electronic gadgets in JEE Main. So how can we calculate this value? So remember, we don't have to calculate the exact value of this expression. We have to simply approximate this. Now if we want to approximate this, we need to rationalize this expression. So this becomes 300 root over 29 divided by 29. Now 29 we can approximately take as 30. This becomes 10, and this expression becomes approximately 10 times root 29. Now root 29 lies between 5 and 6 because root over 25 is 5 and root over 36 is 6. So this expression should belong to the open interval 50 to 60. Now there is only one option corresponding to this interval, so we take this as the correct option. If you calculate this value by using a calculator, the next question, let y equal to yx be the solution curve of the differential equation this, and x lies in this range which passes through the point root over pi by 6, 1. and also passes through the point root over pi by 3 comma beta. Then beta equals, and 4 options are given. So first we have to solve this equation. So first we need to identify the form of the differential equation. Here we cannot make this form a variable separable form because here x and y are multiplied together. So we have to try to reduce it to any other form. So let us try by taking this dx in the denominator. That means this times dy dx plus this equal to 0. And if we take this expression in the denominator of this expression, then we will get the equation dy dx plus 4xy divided by sine of 2x square times log of tan x square equal to 4 root 2 x sine of x square minus pi over 4 divided by sine of 2x square times log of tan x square. So now we observe that this is a simple linear differential equation of first order. That means we have to calculate integrating factor first. Integrating factor will be e to the power, so exponential integral of this function of x multiplied with this y. That means integral 4x dx divided by sine of 2x square times log of tan x square, and we take this integral in the power of e. So this becomes exponential. Then how to integrate this expression? We simply put log of tan of x square equal to t. That means if we differentiate both sides, it becomes 1 over tan x square. So 1 over tan x square times secant of x square times 2x dx equal to dt. And here if we simplify this a little bit, we will get this is equal to 1 by cos x square divided by sin x square times cos x square. So 1 by sine of x square. This will be 6 square. So there will be a cos of x square extra here. That means this becomes (2x) dx divided by sine of x square cos of x square. Now if we multiply 2 in the numerator and denominator, then this becomes 4x dx divided by sine of 2x square. So this is exactly same as this expression. That means here if we substitute this as t, then we get dt by t here. That means integral of dt by t will give us log t, and as there is an exponential function, so that means this will simply become t. This will be equal to t we substituted as log of tan x square. So the solution of this differential equation will be y times integrating factor, which is log of tan x square, is equal to integral of this function in the right hand side times integrating factor. So if we multiply log of tan x square with this, then this will be cancelled. So we will be left with 4 root 2 x sine of x square minus pi over 4 divided by sine of 2x square. Now here, if we open up this sine function, we get 4 root 2 integral, then sine of a cos of b. So we take the 1 by root 2 common outside the integral sign, and this becomes sine of x square minus cos of x square divided by sine 2x square. We can write as sine of x square times cos of x square times 2. So this root 2 will cancel and this becomes 2. That means, and also here is a dx multiplied, and so this will be integral 2x into, this will become secant of x square minus cosecant of x square dx. Now we have to simply put this x square equal to t. That means it becomes 2x dx becomes dt. So this becomes sec of t minus cosecant of t dt. Now this integral we can easily evaluate. So this becomes y times log of tan x square is equal to integral of sec t becomes log of sec t plus tan t minus integral of cosec t becomes log of cosecant t minus cot t plus c, because c is the integration constant. Now here we substitute back t equal to x square, so this becomes log of secant of x square plus tan of x square, and this will be modulus of course minus log of modulus cosecant x square minus cot of x square plus c. Now we are given that this passes through the point root of pi by 6 comma 1. That means we have to satisfy this equation with x value as root over pi by 6 and y value as 1. We get y times y is 1, so 1 times log of tan of pi by 6, which is log of 1 by root 3, is equal to log of secant of x square, which becomes 1 over cos of pi by 6, so 2 by root 3. So this becomes log of 2 by root 3 plus tan of x square becomes 1 by root 3 minus log of, this becomes cosecant of x square is cosecant of pi by 6, so this becomes 2 minus cot of x square becomes root 3 plus c. So from here we get c equal to, this becomes minus log root 3, this whole expression becomes log of 3 by root 3, so log of root 3, and this becomes minus log of root 3 minus, plus log of 2 minus root 3. Now this is equation 1. This is the value of c we got. Now we have to again consider the case that it passes through the point root of pi by 3 comma beta. So now this becomes, again if we substitute y equal to beta, then beta times log of tan of pi by 3, which is root 3, is equal to log of sec of pi by 3, so log of 2, then tan of pi by 3 is root 3 minus, this modulus can be replaced with simple brackets, and then this becomes log of cosecant of pi by 3, which is log of 2 by root 3 minus cot of pi by 3 is 1 by root 3, and plus c. So c we got minus 2 log root 3 plus log of 2 minus root 3. So from here we get that this simplify to log of 1 by root 3, so with a negative sign we get log of root 3. That means this becomes, if we club this two, this becomes log of 2 plus root 3 times 2 minus root 3. So 4 minus 3 is log 1, plus this will become log root 3 minus 2 log root 3. So minus log of root 3. So this becomes 0 as log 1 is 0. So we simply get beta is equal to minus 1. That means beta is equal to minus 1. So option C is the correct option. I hope you understood this question. The next question is based on vector algebra. So as I already mentioned, this is a very scoring chapter. You should not leave this chapter. If you want to do a quick recap of this chapter, check out our one shot on vector algebra. I will link the video in the description. So there I mentioned that how to solve this type of vector equations. So this is a question on vector equations. So here the unknown vector that is to be determined is C, and A and B are given vectors and C is a vector such that C dot A cross B is minus 25 and C dot this vector is 4 and projection of C on A is 1. So we can assume this unknown vector C like a general vector, that is xi cap plus yj cap plus z times k cap, or equivalently we can write this in this notation x, y, z. So we have to somehow create 3 independent equations that can be solved to determine the values of x, y, z. So we look for the conditions in the given question. Now here is the first condition. C dot this vector is minus 25. This is the second condition and this is the third condition. So we have to make 3 equations based on these 3 conditions. So if we dot C vector with this vector 1, 1, 1, it becomes x plus y plus z equal to 4. And if we look into this condition, we get projection of C on A, that is C dot A vector we can write as 430 divided by the magnitude of A, you can calculate it, it will be 5 is equal to 1. So that means 4x plus 3y is equal to 5. This is second equation and this is first equation. And also we have to use this information. So A cross B we can calculate. A cross B becomes I cap, j cap, k cap. Then A is 4, 3, 0. B is 3 minus 4, 5. So it becomes I cap, then 15 minus j cap times 20 plus k cap times minus 25. So this becomes 15 minus 20 and minus 25. So the third condition is that x, y, z dot this vector 15 minus 20 minus 25, it is equal to minus 25. That means 15x minus 20y minus 25z is equal to minus 25. That becomes, if we cancel the 5 from all, so this becomes 3x minus 4y minus 5z equal to minus 5. This is our third equation. So how to solve these 3 equations? Now from here, this 1 and 3 we can eliminate z so that we get an equation in x and y, and there is also another equation in x and y. So there will be 2 equations and we can solve x and y easily, and from any of these 2 equations we can determine the z value. So if we eliminate z from 1 and 3, we have to simply multiply this equation 1 by 5. So we have to multiply this by 5 and then add. This becomes 5x plus 3x, so 8x, then 5y minus 4y, so plus y, and z gets cancelled, and then 20 minus 5, so 15. This is our equation 2a. So solving this equation with 2, we get 4x plus y, we can substitute 15 minus 8x is equal to 5. This becomes 20x is equal to 40. So x is equal to 2. And similarly, y is equal to 15 minus 8x, so minus 1. And then z is equal to 4 minus x plus y. So x plus y is 1 and 4 minus 1 is 3. So our vector C becomes 2 minus 1, 3. So we are asked to find the projection of C on B. B is 3 minus 4, 5. B is 3 minus 4, 5. So projection of C on B becomes C dot B divided by modulus of B. Now C dot B, we can calculate 3 to the 6 minus, no, this will be plus 4 and then plus 3 5s are 15 divided by modulus of B is root 25 plus 25. So this becomes 25 by 5 root 2. So the projection becomes 5 by root 2. This is answer. So we can see option A is the correct option for this question. I hope you understood this question. Let us solve the 18th question. Here it says, if this integral equals px divided by sin x whole to the power 2025 plus integration constant, then p of pi by 3 is asked. So how to solve this given integral? So we separate the given integral into two integrals. That is, we can write this as secant square x divided by sin of x to the power 2025 dx minus 2025 integral, this becomes sin x to the power minus 2025 dx. Now here we can also write this as sin x whole to the power minus 2025. Now if we apply by parts in this first integral, taking this as the first function and this as the second function, because we know that first function is to be taken when the differentiation of that function is easier, and second function becomes that function whose integration is easier. So integration of secant square is tan x, so this becomes easier. So I took this function as the second function. So that means if we apply by parts, it becomes first function as it is times integral of second becomes tan x minus integral of derivative of first, that is minus 2025 into sin x whole to the power minus 2026 times the derivative of sin x becomes cos of x, and also there is integral of second, so it becomes tan x. We can write that in this format, sin x divided by cos of x and also dx, because we are integrating this. and also this expression is here. Now here this cos x gets cancelled and this expression becomes sin x whole to the power minus 2025 times tan x, minus and minus becomes plus, so plus integral 2025 sin x whole to the power minus 2025 dx, minus integral again 2025 sin x whole to the power minus 2025 dx. Now you can see these two integrals will cancel each other, so we are left with tan x divided by sin x whole to the power 2025 plus integration constant, because this is an indefinite integral. So we can compare with the given form. This px is this function tan x, so p of pi by 3 becomes tan of pi by 3, that is root 3. So option C will be the correct option. I hope you understood this question. Let's proceed. The next question is from the topic of differentiation. So you have to apply the rule of differentiation to find out the derivative of hx at x equal to 0. Now hx is not directly given to us. Hx is defined as some composition of some other function g and f. So if we differentiate both sides of this relation with respect to x, we get from the chain rule, we can write that h dash of gx times g dash of g of x times g dash of x is equal to 1. That means h dash of g is equal to 1 by g dash of g times g dash x. Now this is the relation. Now we have to somehow put this g of gx equal to 0 such that here a 0 is created and we get the value of h dash of 0. Now how to find g of gx equal to 0? Then we have to use this information. Now consider this relation as a functional relation, that is g of t equal to 0 for some t. Now what should be the value of t so that g of t equal to 0? Now from this information we can tell that if we put x equal to 0 in both sides, we will get g of f of 0 is equal to 0. So that means f of 0, we can find it from here, it becomes 3. So g of 3 is 0. That means this t should be 3. So now we assumed t to be g of x. So that means g of x should be 3. Now what should be the x value so that g of x becomes 3? We have to find this. Now again we take the help of this expression. We put x equal to 3 both sides. So that means g of f of 3 is equal to 3. So this x is nothing but f of 3. So we have to put x equal to f of 3 so that this becomes 0 and we obtain the value of h dash of 0. So if we put this piece of information in this equation, we get h dash of g of gx is 0, as we discussed. It will be h dash of 0 is 1 over g dash of g of f of 3 times g dash of f of 3. Now g of f of 3 is equal to 3 because g of fx is x for all x. So this expression becomes h dash of 0 is equal to 1 by g dash of 3 times g dash of f of 3. Now we have to find the value of g dash x. How can we find that? We have to find this using this relation. So now we have g of fx is equal to x. So if we differentiate both sides with respect to x, it becomes g dash of f of x is equal to 1 over f dash of x. So this can be written as 1 by g dash 3 times 1 by g dash of f of 3. Now observe a thing, that 3 can be written as f of 0. Here, using the definition of f, we can say that f of 0 is 3. So this expression becomes 1 over g dash of f of 0 into 1 over g dash of f of 3. So we can easily determine these two values from this. This becomes g dash of f of 0 becomes 1 over f dash of 0, and g dash of f of 3 becomes 1 over f dash of 3. Now f dash x we can determine from the given function. It becomes 5x to the power 4 plus 6x squared plus 3. So this 1 over g dash of f0 becomes simply f dash 0, that is equal to 3, and 1 over g dash of f3 becomes simply f dash of 3, that you can calculate. It becomes 462. So the value of h dash 0 becomes equal to 3 into 462, that when we calculate this value, it comes out to be 1386. So 1386 is the correct answer. That means option B is the correct option. I hope you understood the concept behind this question. Now this is the last question of part A, that is the section A, which contained 20 questions, MCQ questions. So this question is from vector, I guess. Let A vector and B vector are two vectors such that A is this vector and B is this, where A and B, these angles, satisfy the relation this. So there is a little touch of trigonometry here. Then the value of 3 tan square A plus 4 tan square B is asked. Now here A and B satisfy this relation. Now observe an interesting thing, that we are asked to find the value or some functional value using the values of angle A and B, but we are given only one equation, that is this. So that means there must be any special condition in this type of questions. So whenever you see that in a question there are less equations than the number of variables to be solved, there has to be some hidden secrets, hidden concepts. So if we dot simply these two given vectors A dot B, it becomes 2 times sin A plus cos A times sin of B plus cos of B. Now from this equation we can tell that 2 into sin A plus cos A times sin of B plus cos of B is equal to 3. So this A dot B is equal to 3. Now here comes an interesting point. We know that A dot B can take the maximum value, which is equal to modulus of A times modulus of B, and A dot B is maximum when theta, that is the angle between A vector and B vector, is 0 degree. That is, the vectors are collinear. So we can say that A vector dot B vector, this maximum value will be modulus of A times modulus of B. So in this case, modulus of A, if we calculate, modulus of A becomes root under 4 sin A plus cos A whole square. So it becomes 1 plus sin 2A plus 1. So this becomes root under 4 plus 1 is 5 times plus 4 sin 2A, and the modulus of B is simply 1 because sin square B plus cos square B is 1. That means modulus of B is 1. So this becomes modulus of A, it is equal to 5 plus 4 sin 2A. And as A dot B attains its maximum value, that means if modulus of A is a function of any other variable, it should also be such that this modulus of A attains its maximum value. That means the maximum value of modulus of A becomes root over 5 plus 4 when sin of 2A becomes 1. Now see an interesting fact, that A dot B was found out to be 3, which is equal to the value of modulus of A times modulus of B when this product is maximum. So that means the vectors must be collinear, and in this case modulus of A attains its maximum value when sin of 2A is 1. So that means A is equal to 45 degree. So we can say that B should be collinear with A. That means their coefficients corresponding to the j cap and I cap, they have to be in the same ratio. So that means cos B divided by 1 is equal to sin B divided by 2 into sin A plus cos A. So A is 45. So we can write 2 into 1 by root 2 plus 1 by root 2. So this becomes, if we take this cos B in the denominator, it becomes tan of B is equal to 2 times 2 by root 2. So this becomes 2 root 2. So we get 3 tan square A plus 4 tan square B. It is equal to, as A is 45 degree and tan B we calculated it as 2 root 2. So this becomes 2 root 2 whole square. So this value is 3 plus 4 times 2 root 2 whole square. We can write this as 8. So this becomes 35. Option D is the correct option. I hope you understood this question.